Today, on TFPmini, I wanted to make some lighting models. Disney parks are full of creative and unique lights I plan to duplicate, and even in miniature scale, my lights need to light up, so this is a great test. So I'm starting with these red pole lights found around the People Mover in Tomorrowland at the Magic Kingdom. I figured this is a good time to dive deeper into how I model my midis, in case you're curious how that all goes. I start with reference photos and use my peeps to figure out how big the lights are, which seems to be around 12 feet tall. Now, in miniature HO scale, that puts them at around 42 millimeters in height. So using 42 millimeters, I first draw a vertical line on the Z-axis that will be 42 millimeters tall. Then I can move, stretch, and rotate my reference photo to match the line, which sets the stage for the whole model. This is not a 100% accurate way to model things. You can see here that the perspective is off a little bit, for example, but it's more than close enough for what we're doing here. Starting with the base, it's a pretty simple shape with some stair-stepping to it. Normally I would switch to the top view so I'm looking down on the model, but this one is simple, and staying in this front view allows me to better see the base. The bottom is a simple circle, so I'll draw a circle that matches the reference photo diameter. Since I don't have a top-down view of the base in real life, I'm going to wing it and just draw some lines that match the general shape of the first stair step in the base. I added some fillets to round out the sharp corners, though at this tiny scale it likely won't matter either way. I'm only drawing 1/4 of the base, then I'll mirror it so I now have a half, then I mirror that to create the full base. Next I use the offset tool, which basically just copies my drawing and allows me to make the same pattern larger or smaller. Now I can select any of those shaded areas and extrude them, which creates my stair steps in the base. Extruding different steps creates individual parts, so I'll combine them into a single object with the Boolean tool. A lot of things at Disney have rounded edges, which is probably a safety thing. I mean, they don't want little kids bashing their heads into sharp edges, so we can use the fillet tool to easily round things off a bit. For the top step, I'll use a bevel instead of a fillet, which almost certainly will make zero difference considering how small the final model will print out. Next up, I switch to a top view and select the top stair step. This becomes my working plane, so anything I draw here will be drawn on top of the top step. So when I extrude it, it will grow out of the top of the base rather than out of the default grid further below. The sides of the light aren't flat. They have a radius to them, so I played around with the various curves until I got a radius I liked. Then I mirrored that for symmetry. I then used the tangent arc tool to make a perfect end curve. Is it 100% exactly the same as the real light? Of course not. Can you tell it isn't when it's only 42 millimeters tall? Of course not. Knowing I want it to light up, I scaled up the shape a bit so I'd have as much room to work with as possible. Now we just extrude it upwards to the height we want. Pretty simple, eh? We might as well fill at the top so there's no hard edges up here too. Now we need to work on the lens where the light shines out of. I'm still very new to modeling, but I figured the best way to do this was to draw a rectangle that would be a bit larger than the lens. Then I can Boolean extrude that shape and taper it at the same time. The Boolean option will cut into the light tower and basically remove the tapered shape I have. I had the idea right, but the wrong rectangle size. And scaling the part up didn't get me where I needed to be either. It just left me with a flat front with an angled side on it. I'll later realize this level of detail isn't seen in the final model, so this was all kind of pointless either way. But until I realized that, I tried again with a larger rectangle. Even though this turned out to be a detail you can't see either way, it's still a good learning exercise. Once I got my final shape figured out, I Booleaned it out of the main light pole. I pushed some of the faces around, and now I have the indent I wanted. To repeat this on the other side, I figured the easiest way was just to cut the model in half and then mirror it. I combined the base and top parts into one object, exported the model, and printed it out. When I test print, I print at high speed and low quality. So what you see here isn't the final quality. The first one is way too skinny to light up, so I stretched the model in X and Y directions while keeping the height the same. I also removed the lens section that will later light up and Booleaned out a tiny 1mm hole so light can shine through the base. Take 2 was better, but still too skinny for lighting up, so I fattened it up a little and printed a clear lens using some clear filament so I could do a real light test. I tried lighting it with a nano LED, like I used in the Mexico food booth, but the base got too much light bleed through it. Then I tried my phone's LED. Not sure what the point of this was. Same light bleed issue, of course. Next, I tried a fiber optic cable, which I really wanted to work, but the light bleed was actually worse. There are options for fiber here, but this model, I just don't think fiber is the answer. It's not great, but as a proof of concept, it shows we're on the right track. Next, I scaled it up a tiny bit more, so the walls around the light hole are thicker, and I moved the LED to just under the lens rather than down in the base. The first lens printed horizontally, so I tried printing one vertically so that the layer lines will end up being horizontal, and hoping that those layer lines catch the light a bit better. This one looks much better. There's still some light bleeding near the bottom of the lens that I'll have to tweak a bit. It's crazy how sometimes a small project like this becomes a big project. When something is super complex, like the Japan pagoda that I just did recently, almost seemed easier at times. As you can't tell at all in this blurry footage, I modified the light to be just a butt hair thicker in the X and Y directions, and made a little pocket for the LED to better sit in. I printed up 18 or so of the lights, airbrushed them all in red, then hand-painted some gray base detail onto them. Better print out 18 lenses as well. Even though I only need 15 total lights, I very much plan to break a few of these along the way. The lenses got a sanding treatment to sort of frost them up a bit. In my mind, this makes them refract the light better, but in reality it probably didn't do all that much. After assembly, soldering of the world's smallest wires, adding a battery, and printing an arc-type thing for nothing more than the following shot, well, let's check out the final result. Oh, hey there. Oh, you're still here, eh? Well, this is a little awkward because, the video's over now. Okay, hold on a second. No worries. Here you go. Here's a little something I handpicked just for you to watch.